Homework day 25. It's going to be the end of chapter 4. A whole bunch of word problems on here. It says on the first one, at a hockey game, a vendor sold a combined total of 162 sodas and hot dogs. The number of hot dogs sold was 46 less than the number of sodas sold. Find the number of sodas sold and the number of hot dogs sold. So we have two different unknowns. We have the sodas, I'm going to use an S for that, and the hot dogs, I'm going to use an H for that. Since we have two unknowns, we have to have two equations in order to solve our problem. Sometimes we'll solve it by substitution, sometimes we'll solve it by the addition method. It says here, at a hockey game, the vendor sold a combined total of 162 sodas and hot dogs. So one of my equations has to do with a total. Total means I'm going to add the number of sodas plus the number of hot dogs is the 162 combined total that I had. My other equation is going to come from that second sentence. The number of hot dogs sold was 46 less than the number of sodas sold. When I'm writing that second equation, whatever thing is mentioned first, that's the variable that's going to be set equal to something. The number of hot dogs, H, was, so there's where my equals is. The hot dogs is going to be written in terms of the sodas. The number of hot dogs sold was 46 less than the number of sodas. 46 less means I take 46 away from the number of sodas that I sold. And subtraction, the order is important, so be careful that you put minus 46 on the end, not 46 minus S. So on this one, we're going to solve this one by substitution. Since this equation is solved for H, we're going to replace the H in this first equation with that S minus 46. So in that spot, S minus 46. And so now I'm going to have S plus S minus 46 equals 162 for my equation. I need a lot more writing room. And so, since I'm adding those, I really can just drop my parentheses and go ahead and combine my like terms. I have an S plus another S, so I have 2S minus 46 equals 162. Putting the S plus the S together. Solving that, I would have to add my 46 to move it to the other side. So 2S is going to equal, if I add that, I get 208, I think, if I added that right. And then, of course, I have to divide by 2. So 208 divided by 2 would be S equals 104. I sold 104 sodas, right? 104. I still need to figure out how many hot dogs I sold, so I'm going to go over here to this equation that's solved for H. My hot dogs was 46 less than my sodas, so if I take 104 and I subtract 46, if you subtract that for me, what do you get?
Equals 58.
58. So 58 hot dogs. So we had 104 sodas, 58 hot dogs.
Huh.
I'm going to put some space in there because that was not near enough space for me to write. We'll just move number 2 to the next page. And give him a bunch of room. And so now if we look at the second one. The second one says the sum of two numbers is 55 and the difference is 17. What are my two numbers? So the first equation, the sum of my two numbers is 55. I have a larger number and a smaller number, so I'm going to use L and S, even though my S's sometimes look like 5. I just have to remember it's an S. Sum of two numbers, sum means I'm going to add. So L plus S equals 55. And the difference is 17. Difference means I'm going to subtract my two numbers. So L minus S is 17. Notice on this one I lined them one above the other because I don't have one that's solved for just one variable. It didn't say the hot dog was or anything like that. So this one, since my variables are both on the same side, I'm going to do that elimination method. I could make opposites in front of my L's, but I already have opposites in front of my S's. So since these are already opposites, all I have to do with those two equations is add them together. One L plus another L would be two L's. The S's are opposite, so S minus S would cancel each other out. And then I'm going to add the 55 plus the 17. 72. So in order to solve that for L, all I need to do is divide by my 2. L is going to equal 72 divided by 2, which would be 36 then. So my large number is 36. Found my larger number. I still need to know what my smaller number is. I can substitute it into either of my two equations that I have up there, but the one with the plus sign is usually an easier one to plug it into instead of the one with the minus, and then I have to deal with that negative. So I'm going to put 36 in for the L. 36 plus my small number equals the 55, which was the sum of my two numbers. And so in order to solve that, I just minus my 36 to move it to the other side. So if you take 55 minus 36, you get
19.
19.
S equals 19.
Now if you wanted to check that to make sure that seemed right, the sum of those two numbers should be 55. The difference should be 17. If you take 36 minus 19, what do you get? 17. So it checks out. If you add them together, you get 55. If you subtract them, you get 17. I must have the right two numbers. Forgot, I got to go up here and do that. Get it to work right. Now I got to add some more space to my third one so that I have plenty of room to write. So next time. All right, so the third one. At a basketball game, a vendor sold a combined total of 219 sodas and hot dogs. The number of sodas sold was 2 times the number of hot dogs sold. Find the number of sodas and the number of hot dogs sold. So again, I'm going to use S for my sodas and H for my hot dogs. And I want to write my two equations. So at my basketball game, a vendor sold a combined total of 219 sodas and hot dogs. How can I write my equation to represent that first sentence?
S plus H equals 219.
S plus H equals 219. My second one, the number of sodas sold was 2 times the number of hot dogs sold. So how do I write the equation for that second sentence?
S equals H times 2.
And how do you show H times 2?
H2.
Or?
Or 2H.
2H, right? The number in front of the variable. So the sodas were mentioned first, so we knew it was S equals something. It was equal to 2 times the hot dogs, so 2 H's. So we can solve this one by substitution. We're going to replace the S with 2 H's. So now our equation says 2H plus H equals 219. I can combine my like terms. I have a 2H plus another H, which would be
3H.
3H. 3H equals 219. And then I'm going to divide by 3. 219 divided by 3.
73.
73. 73 is the number of
Hot dogs.
hot dogs. I still need to find the number of sodas. How am I going to find the number of sodas?
2 times 73.
2 times 73. My soda is 2 times my hot dogs. So 2 times 73 would give me
146.
146. So I have 146 sodas sold and 73 hot dogs sold. Then we go to a totally different thing, which is graphing inequalities. When we graph an inequality, we graph it the same way we did with the equal sign. Then we have a little few other things to do to it. So first ones are going to be the ones where we had a vertical or a horizontal line. We said where our lines went vertical if they had x equals the number. They're horizontal. Whoa.
Whoa.
That really went crazy on me. Let's see if I can get it back. Where we had y equal. Oh, criminies. It's not one thing, it's another. Am I writing too slow? Y equals my number. Oh, nope. I don't know why it's doing this. This is a new one. Of course, they put different software on here. We'll just put that up there. Let's see if that works. I got the calculator there, but oh well. Wait. So I'm going to graph y equals 4. I'm going to pretend that's what that says. Y equals 4. We said we knew that that was a horizontal line that touched my y-axis at 4, right? So we said, oh, right there's where y is equal to 4. And then we said, well, we could just make a couple dots. We know it has to go horizontal, so it would look something like that, where I have a dot on the left and a dot on the right so that I can draw my line. I could draw straight. Otherwise, you could make a table and put all your y values as 4 and pick some numbers to put in there. What did I use? I used 3 and -3 and plot my points and get them that way. But if I know it's going to go horizontal, I really don't have to go through the process of making a table unless I want to. Now, the next thing I need to decide, if it has the less than or equal to or the greater than or equal to, we want to have a solid line like we had to draw it. However, if it doesn't have the equal to bar underneath, we're going to change it to a dashed line. So there's a little tool that looks sort of like this. We're going to click on that tool, we're going to click on the line, and the line's then going to be a dashed line instead of a solid line. This one didn't have the equal to, so we knew it had to be a dashed line instead of the solid line. Once we have the right line, then we're going to shade. If I'm thinking about my y-axis, greater would be above the line, less than would be below the line. Where are my y values less than 4? Well, underneath here. Now the tool looks something like this with a bunch of little dots. You'll click on that tool, click anywhere below that line. It'll fill that whole section in for you with a whole bunch of little dots and shade everything below the line. Suppose if I close my calculator, it will like me. Nope. Clear. So number 5 wants us to graph x is greater than 5. So if I'm going to graph x is greater than 5, what kind of line am I going to have? Oh, which one?
Dash.
First of all, which way is my line going to go? I got to get my line on there first.
That's a vertical line.
It's a vertical line, goes up and down. X equals 5 would be right there. We know it goes up and down. Now when we draw it the first time, we have to draw the solid line in on Alex. Then we have to look to see if we have to change it. And you said, yep, we have to change the line. This one has to be dashed because we don't have the equal to. So we use that little cute tool and click on our line, and then the line becomes a dashed line instead of a solid line. Then we got to do our shading. This time we're looking at the x-axis. Greater than goes to the right, less than goes to the left, just like your number line. I'm shading greater than 5, so all the stuff over here will be shaded. You just have to click once, it'll fill the whole thing in on your paper. You can just scribble it in. So number 6 there, we are doing x is less than or equal to 6. So again, if it's x is less than or equal to 6, which way is our line going to go? Up and down. So on my x-axis I mark 6. I know it's a vertical line, and so then I draw my line x equals 6. Now should my line be solid or should it be dashed?
Solid.
Going to be solid. We do have the equal to, so this time we just leave it alone and leave it a solid line, and then we're going to shade. What side of our line should we shade?
To the left.
To the left, because we're doing less than. So it's going to shade in all this big section over here with a whole bunch of little dots, and our graph will look something sort of like that. Number 7 then. Whoops, I got to clear it. I'm used to just clicking on the board and it clearing it. So number 7, we want to graph y is less than or equal to negative 5x minus 1. So again, we're going to pretend it's an equal, and we're going to do y equals negative 5x minus 1. So when we did our table, we picked nice easy numbers like 0, 1, and 2. Maybe you want to use a negative 1. You just pick some easy numbers and you plug them in. If x is 0, what did we get for y?
Negative 1.
Negative 1. Negative 5 times 0 is 0, and 0 minus 1 is still minus 1. We knew that should be our y-intercept anyway. It's going to touch our y-axis at minus 1. If we put 1 in for x, what are we going to get?
Four.
Nope.
Negative 4.
Nope.
0 or 1.
If you put 1 in for x, negative 5 times 1 minus 1. Negative 5 times 1 is negative 5. A negative 5 minus a 1.
Oh, it's a positive. No.
Add and keep the sign. Negative 6. So over 1, down 6 is where my dot's going to go.
Oh,
Now I can see if I put a 2 in there, it's going to be way off my graph. So I'm going to skip 2 because that's not going to fit. And I'm going to use negative 1 instead. So if I put negative 1 in for x, negative 5 times negative 1 minus 1. 5 minus 1 is 4, right? So if x is negative 1, y is positive 4, are going to be up there. We knew our slope was negative 5, then to get from one point to the next, I'm going to go 1, 2, 3, 4, 5, down and over 1. 1, 2, 3, 4, 5, down and over 1. Sure enough, that's what I do. I go 5 down and over 1. I now can draw my line. I've got my line on there. Then I decide, should it stay solid or should it change to a dash line?
Solid.
Should stay solid because it does have the equal to, so it is going to be solid. And then I got to think about shading. I'm thinking about the y-axis, so I'm thinking about, do I shade above the line or below the line? Y is less than. So here's what I do. Here's my y-intercept. If I go less, I'm going straight down the y-axis. That's going to tell me the side I should shade on, the side where I drew that line. So it looks like I'm shading on the left side of that line. Technically, I'm shading below that line because your y-axis goes up and down, not left and right. But y is less than, I shaded below my line. So I just find my y-intercept and go straight down on my y-axis, and then I can see which side of the line I'm on. So number 8, we're graphing y is greater than x plus 2. We're pretending it's y equals x plus 2. So if I make a table and pick some points, what might I want to put in for x? 1,
3.
3. I was like 0 because that's my y-intercept. So if x is 1, what is y going to be?
3.
3. 1 plus 2 is 3. If x is 3, what is y going to be? 5. 3 plus 2 is 5. If x is 0, what is y going to be? 2. That n number, right? So 1 over up 3, 3 over up 5, and 0 over up 2. What's the slope on that line? You know, we did that, we picked those out the other day. What is the slope of that line? The slope of that line is 1 because this is a 1x, right? Means to get from one point to the next, I went up 1 over 1, up 1 over 1, up 1 over 1. If I kept doing that, I'd have a whole bunch of dots, up 1 over 1. But we can see it's a positive slope, that when we connect our dots, it goes uphill as I go from left to right. However, if I look at that line, should that be a solid line or a dashed line?
Oops, it should be a dash.
It is going to get changed to a dash. On Alex, you have to draw it solid and then change it after you've got it drawn in there. And so now I got to make it a dashed line instead. So now I want to shade y is greater than my line. If y is greater than, what direction am I going to go?
To the right.
Or up or down? I'm going up, right? Y-axis goes up and down. So I'm going up from my y-intercept, which to me looks like it's actually on the left side of my line. So you don't want to think right or left when you're looking at y. Y is always up or down. X is right or left. And number 9 here, we're going to pretend it says y equals negative 1/2 x minus 4. And then we're going to pick some points to put in there. What might we put in for x? Zero is always a good one. If x is 0, what is y going to be equal to? Negative 4. It's just going to be that n number. What's another number that would be good to put in for x? Probably not 1 unless I want to deal with fractions. If I have 1/2, what would be good numbers to put in?
2.
2 would be a good number. We want multiples of the denominator. So negative 1/2 times 2 minus 4 would give me what for an answer?
Negative 6. Negative
3.
I don't get either of those answers.
Negative 3. No?
What happens when you take negative 1/2 times 2?
You get negative 1.
You get negative 1 because the 2's cancel out. What's a negative 1 minus a 4?
Negative 5.
Negative 5, because I got to add and keep my sign, right? We did fractions in that review chapter. You can't forget those. What's another good number to put in for x?
4.
4 would be probably a good number. So negative 1/2 times 4 minus 4. What's going to happen there?
Can cancel.
2 goes into 4 2 times. Negative 1 times 2 is negative 2, and negative 2 minus 4
Negative 6.
is negative 6. So 0, negative 4, which is our y-intercept, 2, negative 5, and 4, negative 6. Our slope here was negative 1/2, right? The number in front of the x was negative 1/2. Means to get from one point to the next, I go down 1 and 2 to the right. Down 1 and 2 to the right. Right? Change in y over the change in x. And then, of course, on Alex, I have to draw my solid line, but then I look at my inequality and say, oh, should that stay solid or should I change it to a dashed line?
That's dash.
That's got to be a dashed line again. So we use our cute little tool, click on our line and make it a dashed line. And then I have to figure out my shading. Y is less than my line, so should I shade above that line or below that line?
Below.
Below. Here's my y-intercept. If I go straight down, I'm shading down here. And that's what my graph would look like then. That must be the end of chapter 4.